Good day, viewers. Welcome to the Physics Mind. Today, we are going to look at another question from projectile motion. So let's dive into the example. Okay, so the question says that a body is projected from the ground at an angle theta to the horizontal with a velocity of 30 meters per second. If you reach a maximum height of 11.25 meters, calculate 1. The value of theta, 2. The time taken to strike the ground, 3. The range, and 4. Its velocity 2 seconds after projection, and we are given g to be 10 meters per second square. This is a NECO question 2004. Okay, so let's write down the parameters given from the question. So we are told that a velocity of what? 30 meters per second. So it means the initial velocity u is 30 meters per second. And it reached a maximum height of 11.25 meters. So it means that the maximum height h is equals to 11.25 meters. Okay, so we're asked to calculate the value of theta first. And we are given g, which is the acceleration due to gravity, to be 10 meters per second square. Okay, so that gives us the parameters. So the first thing we have to do is the value of theta. How do we obtain the value of theta? So to obtain the value of theta, we obtain it from the equation for the what? The maximum height of a projectile. And we know that the maximum height of a projectile, h, is equals u squared sine square theta over 2g. Please, if you don't know how we obtain this equation, go back to our first video and see how we derive the equation for the what? The maximum height of a projectile. So substituting the values, that will give us a maximum height, which is equals 11.25. So we have 11.25 should be equal to u square, and u is what? 30. So we have 30 square. Then sine square theta over 2 times g, and g is what? 10. Okay, so that is going to give us 30 square, which is 900, and then sine square theta over 2 times 10, which is 20. So that implies that 11.25 should be equals 900 sine square theta over 20. So we're looking for theta. What we need to do now is what? To cross multiply. So we have 11.25 times 20 should be equals 900 sine square theta. So 11.25 times 20, I'll use my calculator, times 20, that is 225. So 225 is equals 900 sine square theta. So we're looking for theta. What we need to do is to divide both sides by 900. Divide both sides by 900. So this goes with this. So we have sine square theta should be equals to 225 divided by 900. So 225 divides 900, which is equals 0.25. Okay, so we are looking for the value of theta, and we have sine square theta to be equal to this. So for us to find the value of theta, we need to first of all get rid of this what? Square. And for us to get rid of the square, we need to introduce what? Square root. So we need to take the square root of both sides so that the square root on this side cancels this. So taking the square root on both sides, the root goes with this, so we are going to be left with sine theta to be equal to the square root of 0.25. So sine theta will be equal to, so square root of 0.25 is equals 0.5. So we're looking for theta, we take sine inverse. So theta will be equal to the sine inverse of 0.5, and theta is equal to the sine inverse of 0.5, which is 30 degrees. So therefore, our theta is equals 30 degrees. Okay, so let's go into the next example, which is the time taken to what? To strike the ground. The time taken to strike the ground. So we're looking for time taken to strike the ground. Okay, so the time taken to strike the ground in this case is the what? The time of flight, because the projectile has been projected into space and is the total time taken by the projectile, or the total time spent in air by the projectile. So the time taken to strike the ground in this case is not the same as the time taken for the object to move from the maximum height and then to get to the ground. No, it is a what? The entire time what? Spent by the projectile. And that entire time spent by the projectile is the what? The time of flight. And of course, we know that the equation for our time of flight is equals to 2u sine theta over g. Okay, so we have already derived the equation from our first video. Please check the first video for the derivation. Okay, so our time taken t becomes, let's substitute our values. So we have 2 times u, which is what? Initial velocity, 30, multiplied by sine theta. We've calculated theta already to be 30 degrees. So divided by g, which is 10. So that will give us 2 times 30, which is 60 sine 30 over 10. Okay, so t will now become 60 times sine 30, which is equal to 30 divided by what? By 10. So 30 divided by 10, that will give us 3 seconds. So it means that the time of flight is equals 3 seconds. So the next thing we have to find is the range of the projectile. So to find our range, R, of course, we know that our range is equals to u squared sine 2 theta over g. Okay, so substituting the equation, our values to our equation, we have u squared, which is equals to what? 30 squared, then sine 2, theta is still 30 degrees, then divided by what? By 10. So that will give us our range to be 30 squared, which is 900, sine of 2 times 30, which is 60, then divided by 10. So our range now becomes 900 times sine 60, 900 times sine 60, that is equals to 779.42. So divided by 10, so that will give us 77.94 meters. So that gives us the what? The range of the projectile. So the last thing we're asked to find is its velocity 2 seconds after projection. Okay, so we're looking for the velocity of the body 2 seconds after projection. Now remember that a projectile at every point in time has 2 independent velocities, except at the what? The maximum height, where the projectile is only having the what? The horizontal component. So it means that after these 2 seconds, the projectile still have what? Vertical component and horizontal component. So it means since we are looking for the velocity after 2 seconds, we need to obtain the what? Its initial component and also its vertical component. Then we'll find their resultant. That will give us the what? The vertical component of the what? The initial velocity. Okay, so let's find the horizontal component of the initial velocity, which is equal to what? Ux. So since the projectile is inclined at an angle to the what? The horizontal, Ux we know is going to be equal to what? U cos theta. So u we are given to be 30. So 30 cos 30, that will give us, so I'll use my calculator to evaluate that. So 30 cos 30, which is equals to 25.98 meters per second. Okay, so the next thing is to find the vertical component, which is what? Uy. And Uy is equals U sine theta. But then, after a time t spent by the projectile in air, the vertical component of the initial velocity does not remain what? The same. Remember that throughout the period of motion, the horizontal component of the initial velocity remains constant throughout the period of what? Of motion, or throughout the time of flight. But the vertical component keeps what? Changing. And what is the nature of the change? As the projectile keeps what? Going upward, the vertical component keeps what? Reducing, 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 and it finally becomes what? Zero at the what? The maximum height. So it is going to be reduced by a factor of what? Of gt, which is the what? The product of the acceleration due to gravity and the what? Time spent by the projectile in what? In air. So once it becomes zero at the maximum height and the object starts what? Coming back to the ground again, the vertical component will again start what? Increasing, increasing by the same factor of what? Of gt. That is going to become what? A plus gt, and then it becomes maximum once the projectile what? Strikes the projection plane again. So that is the what? The nature of the increase and decrease in the what? In the vertical component of the what? The initial velocity. So however, vertical component is only equal to what? U sine theta at the what? The point of what? Of projection. But once the projectile spent a time t in air, then vertical component does not remain the same, but it what? It reduced either by a factor of what? Minus gt, or it will increase by a factor of what? Plus gt, depending on whether it is an upward motion or it is a downward motion, as governed by what? By gravity. Okay, so however, the projectile is still in motion. So it's what? After it has been projected. So it's still going against gravity. So we have minus what? Gt. So let's obtain the value of uy. So our uy now becomes u, which is 30, sine theta, we've already calculated it, which is 30, minus gt, which is on 10 times the time taken by the projectile, or the time spent. We are asked to find the velocity after what? 2 seconds. So our time there is what? Is 2. So you can see that what the vertical component is what? Is time dependent, because it's depending on the time spent by the projectile in air. Whereas our horizontal component what? Is constant. It's independent of what? Of time. So our uy now becomes 30 times sine 30. Sine 30 is 0.5. So 0.5 times 30, that will give us 15, minus 10 times 2, which is 20. So uy becomes 15 times minus 20. That will give us minus 5 meters per second. Okay, so we found the horizontal and the vertical component. The next thing is to find the resultant, since they are always at right angles to each other. So this becomes a vertical component, horizontal component, and this becomes a vertical component, and this becomes the resultant u. So this is uy, which is minus 5 meters per second. This is ux, which is 25.98 meters per second, and it's inclined at an angle, let's say phi, to the horizontal. So the next thing is what? To find what? U, using what? Pythagoras, since the two components are always at right angles to each other. Okay, so to find u, we have that what? U will be equal to the square root of what? Ux squared plus what? Uy squared, which is equal to the square root of ux, we already know is what? 25.98 square, plus uy, which we know is what? Minus 5 squared. So u becomes the square root of, so I'll use my calculator. So 25.98 square is equals 674.96 Now, plus minus 5 all squared is equals to plus 25. So we add them together, 674.96 plus 25 is equals 699.96. So our u now becomes the square root of 699.96. So that will give us 26.45 meters per second. Okay, so this actually gives us the what? The actual velocity or speed of the body just after what? 2 seconds. So when you compare this speed and the initial speed of the projectile, which is 30 meters per second, you can see that after 2 seconds, the velocity what? Reduced to what? To 26.45, telling you that what? The more time the projectile spent in air, the what? The lesser the what? The velocity of the what? The projectile becomes. However, so let's find the what? The angle of inclination of the projectile after that what? 2 seconds. Okay, so to find the angle, let's take tangent of this angle. So we have tan phi. Tan phi is opposite of our adjacent. So what is opposite this angle is uy. So we have uy over ux. Okay, which is equal to our uy, we know is equals minus 5 over ux, which is 25.98. Okay, so our tan phi becomes minus 5 divided by 25.98. So 5 divided by 25.98, which is equals, 5 divided by 25.98, which is equal to minus 0.1925. So phi will now become the tan inverse of minus 0.1925. So phi becomes the tan inverse of 0.1925, which is minus 10 point what? 89 degrees. So this gives us the what? The angle of the inclination of the what? The initial speed to the what? The horizontal after that what? 2 seconds. All right, thanks for watching. Please make sure you like and subscribe to my channel for more videos like this. Bye.